All right, so at the moment, thanks lads, we've got our formula here. When do we use this? Well, you said when we don't know the last term. When we're just looking at the terms, we're not wanting to add the terms together. Okay, so just technically sequence. Now, some questions and some books aren't so particular with series and sequence, and so they might even say, you know, 1, 2, 3, 4, comma, comma, comma. They might call that a series. Well, they're just... So basically, when you're adding together series, and that's when we're using these formulas. And I think as someone then said, why have we got the 2? Well, if you have the last term, you use this one. If you need, if you don't have the last term, you have the first term number and the difference. You can go that. Sometimes when we're working with series, and part of a question means that we do have to go back to our sequence formula in order to find some unknown terms. So we're looking at both of those. We then went on to look at, not that, but geometric. I hope it's there. Not yet. Boy, we did a bit. Oh, okay. Didn't have it up there. But geometric series, and that is when we've got, sequence. That is when we've got A, R, N, take 1. And like we had before, what does the N stand for? Oh, what does the A stand for? The starting term. So first term, but this bit is the new. Right? N is the same, but R is now the common ratio. And I asked you to remember one thing. What was that? My birthday is... No. The common ratio, it's the same that we do it with the common difference, is that you have to do like the second term divided by the first one, the third one divided by the second one. And that's very important because obviously, let's imagine if we had 2, 4, 8, 16. If you just decided to work out your common ratio going from left to right, your ratio would be 2 over 4, you get a half, as opposed to right to left, 4 over 2 is 2. So you must always... And fancy pants, how we do it is we say Tn plus 1 over Tn. And by now, you're going, yeah. I know what that means. Because if this is the Tn term, the one that comes next is then Tn plus 1. It's just notation. It means next term. Correct? We all good with that? Yeah. So really, you're just... trucking through, and remember, some of us, I know, we didn't actually do the 15B with the series. 15C. We didn't finish, some of you were still finishing 15C up to 24 or 20, I can't remember what I said, and we did some of these. So, have we got any questions thus far from our common ratio? No? So you're working your way through 15D, and I've forgotten what we were meant to get up to. So just revving up for a geometric sequence, find the first 4 terms, given that we've got A is 3, ratio is 2. So for A, we just plop it into our formula here. You might want to get used to writing it down, and then it just becomes second nature to you. You don't have to be memorizing things, it's just bang, there. All right, so therefore our general term will be Tn3 times 2 to the n take 1. So if I now want my first 4 terms, when n is 1, T1 will be 3 times 2. Now 1 take 1 is 0, and anything to the power of 0 is 1. 1 times 3, 3. When n is 2, T2, so it's just subbing. 3 times, ratio is still 2. 2 take 1 is 1. 6. Okay, you can probably get the gist soon about what is your I mean, because the ratio is 6, they're just timesing it by 2 every time. So do you have to keep slapping it in? 3, 6, 6 times 2. 12, and double check that. If you put 3 in here, 3 take 1 is 2, 2 squared is 4, 4 3s are 12. And you go, oh, I don't even have to bother subbing in because I know the fourth term will now be, yep, times by 2, 24. Huzzah? Say again? Now, had a great question and I wanted to dive in, but we're at different parts. I think I need to bring us all back together. Don't look at the board yet. You guys, when we did the arithmetic sequence and you were told, oh, the fourth term is this and the eighth term is this, remember we ended up with simultaneous equations. And you just subtracted one from the other. We're good? Well, you're going to get the same thing with geometric. Here's a lovely example. So it's just right at the start of all of the questions. We've got the third term, so T3 equals 10. T3 equals 10, agreed? And then the sixth term is 80, T6 equals 80. So you pop that in, but this time, instead of subtracting one from the other, because you wouldn't be able to, again, that's not how I do it, you divide one by the other. Divide, and look what happens. What's A divided by A? Correct, it cancels. R to the 5 divided by R squared, what happens when you're dividing by the same base? Subtract the powers, and then 80 divided by 10 is 8. Now, how do you get, I mean, this one we know. You can look at that and go, I know, what cube gives me 8? We should know it's 2. How would you do it, Arush? How would you do it if it was something like you were left with maybe R to the 5 equals, I don't know, 382? So we take the fifth root of 382, or you can say 382 to the 1/5, okay? So how do we do this? Obviously, I think you just use you know how to use your power button on your calculator for this. For this, look on your graphics calculator. I should have opened it up, but I did not. All right, it's called the nth root. It's right above near your brackets, I think. Is it?
It's right next to the original.
Oh, right next to the original root. Oh, the cube root is above the brackets, correct?
Yeah.
This should be something that you can add to your notes section, right? When you do the arithmetic ones, we're doing solving simultaneous equations by elimination. Here we're solving two simultaneous equations, so this and this. We're doing it by you divide. And once again, every time, A divided by A, it's always going to cancel out. All right, the textbook is actually not too bad because it will say, look at examples, so scooch back up and have a look. So please, let's get on that. We've got a little bit of work to do. I will pop up. I just want to put 2 more worded questions. There's 8 questions in your worksheet. I'm just going to put 2 more questions up. Can you please do it on a piece of either graph paper or pad paper? And it's only on arithmetic sequences and series. So how about we combine and we get together